Good morning. My name is Krishnananda Shenoy. I am from Infosys IoT practice. So I'll not take much time. My session is very small, just to introduce the upcoming speakers and the topic. I'm not going to give a lot of data on 50 billion devices and all that. I'll just introduce some of the practical things, what we are seeing in IoT, some of the practical challenges. As we see that, IoT is not hype anymore. It is matured. Everyone is adopting IoT. Every industry is adopting IoT. So, as Fred said, once you start adopting, then only you will see what is the shortcomings, what are the challenges. And that's what we are also seeing, some of the challenges. If you look at IoT, everybody just talks about data, right? But it's not just data. If you want to realize any IoT, it has to be put in perspective of what you are solving the use case. That's why it needs a multi-technology, multi-engineering skills. If you look at IoT today, mainly it is adopted in industrial world. You of course have a lot of these consumer examples, wow examples of whatever wearables and Fitbits, but if you look at the larger adoption, it is in the industries, whether it's oil and gas, mining, manufacturing, where the actual ITOT integration is happening. And this is where we are seeing a lot of challenges. One, it requires multidisciplinary knowledge. It requires engineering, IT and data science knowledge. It requires knowledge for integrating multiple stacks, and that is where I think we would be interested to know from the IETF perspective and some of the speakers, what are the challenges that is going to happen across the stack, not just the sensors or the connectivity stack, right, or the enterprise stack. So this is what we are seeing. If you look at the way we are looking from a technology perspective, there's 5 layers to this stack. There are multiple versions of the architecture. You have the devices where actually it could be a machine, it could be a sensor connected to a machine, or it could be a PLC, DCS systems in a plant automation or a manufacturing facility which generates the data, and that data is somehow transported using some connectivity mechanism, wired, wireless, whatever, what have you. You data aggregate and then you connect to some kind of a systems, and then you derive the intelligence or insights using the analytics. Now, these are, typically 5-layer stacks. What we are seeing is how do you transport the data? And each industry, each use case has different examples, because in manufacturing you might have a time series, high frequency sample data that you might have to really sample at sub-seconds or even seconds. So that is the kind of data that you might be generating. And how are the technologies available today to transport such kind of a high frequency data? And some of these data requires low latency transportation mechanism, especially if you see in a industrial world, working on the second or the high frequency data is very, very critical. And why I'm bringing this again is what we are seeing is 80% of the deployments out there are brownfields. Right? All the manufacturing facilities that are like brownfields, which have been probably set up 20 years ago, and the networking infrastructure there is also probably equally old. So that is not sufficient for processing that kind of a data that is required for IoT kind of use cases. That's why there are lots of concepts that have been talked about, edge and fog computing. You don't compromise on processing the data, taking to the cloud. You cannot. You have to do it at the edge, because you have that latency requirement especially in an industrial world, there's a lot of not only monitoring, control systems also you need to control. So that cannot wait for a latency of going to the cloud and then coming back. So there's so much of requirements of processing the data at the edge itself. We don't have very clear connectivity management. We are looking at SDN and some of those dynamic configured networks that we are talking about today. These are the things that have to be integrated, and you have to see as a whole, manage this end to end. because we are looking at siloed systems. Whenever I talk about these 5 layers, each of these are managed in its own silos, but that is not going to help. You need to have an end-to-end management, management solution. I'm not going to talk too much about security and all. It's already, we are going to have sessions on that. There's also a lot of discussions around cloud or on-premise, right? Although we have so much of applications running on cloud today, some of them may not suffice for the requirements of the ITOT integration. This is typically what we see in an industrial network. I bring this up because traditionally the systems in the operations technology in industrial world, whether it's mining, oil and gas, or simple manufacturing, they have set up operations technology. You would have heard about terms of SCADA and plant automation control systems. They are totally siloed, isolated systems. They were never connected to IT network in a factory or in a mining industry. Today, we are looking at connecting these two. When you're talking about industrial IoT, there's a discussion about connecting IT and OT together, because everything now will get into the IT network. You're talking about data analytics, connecting the data from the sensors and running some of these processing will be done with a combination of ITOT integration. Now, what will that happen? Why I'm bringing this up? We have seen typically this is the data challenge, volume, variety, velocity. But when you bring the industrial scope into picture, we also look at validity of the data. What I mean by validity of data is, if you don't act on the data within that given time frame, it loses its value. For example, let's say there's a control valve which is open and you get the data. If you don't act within that time, anything can happen. Imagine if it's a turbo engine or a turbine in a power plant, and when you're doing all this in an IT stack, not in an OT stack, you need to act in a sub-second manner of that particular data or that event that is getting generated. So that's why I'm bringing the validity of the data into picture. Why? Because now this validity of the data will determine how is your underlying network, how deterministic is your underlying network. Because in the industrial world, some of the networks are all deterministic. When you're running it on an RS-485, RS-232, protocols like Modbus and all, they are very, very deterministic in nature. So you can really characterize that a point A to B will be transferred within sub-second, right? But the same thing when you bring IT layer, industrial network, TCP IP into picture, we need the same determinism of the network behavior so that you can act on that data. So that's why I'm bringing the validity of the data into picture. And this is what is going to be key when we do an ITOT integration or bringing IIoT, Industrial Internet of Things. This is going to be a very, very key thing. So this was my introduction. I will now call upon various speakers who will talk about various aspects of the IoT. Starting from Karsten from TZI, who's going to talk about the IoT landscape in IETF. We heard from Fred that there's no specific thing called IoT as an area in IETF, but as you saw from the technology stack, it's going to be an horizontal. A lot of things is going to really impact IoT, right? Followed by Karsten, we'll have Sam, who's going to, he's from NTT, who's going to talk about security in the IoT. Obviously, we have seen a lot of issues caused by security. There are things like how IP cameras really brought down the entire internet because somebody hacked into the cameras, and then a lot of DNS queries were generated. Followed by Sam, we'll have Rahul from Huawei, who's going to talk about compression in IoT protocols. This is going to be, again, very key because you see that 50 billion devices and the data tsunami you're going to have, how you can have a very low bandwidth network can be utilized for transferring the same amount of data. Probably compression is going to be very, very key. Followed by Rahul, we'll have Elliot from Cisco, who's going to talk about evolving IoT security. So I think it's going to be a very informative session, and I'm sure there will be a lot of questions asked by the speakers to us. I would now call upon Carsten to take to the next session.